Okay, so today we're going to go over the practice guide. We have the second half today, so I'm going to go through this pretty quick. Make sure you have your practice guide out in front of you. Remember, this is due tomorrow, completed, which you should already have the first half completed. If you haven't already, watch the video online. I posted it last Thursday or something like that. Video is online, so you can watch the first half review. We went through the first 5. Today we're going to be doing the second half today. To kind of go through it. Remember, vocab words, I kind of warned you that some of these words are going to be on there, some won't. There's some easy changes I can make there. So make sure that you're flipping through that. And you're kind of checking, because remember, at some point, there's a bunch of theorems at the bottom you need to be aware of. Okay? So be cautious. There's going to be 6 or 7 theorems that you need to kind of be aware of. Okay? Number 1, this problem you need to use the interior angle formula, which is technically question number 2, but that one requires the interior angle formula to know what they all add up to be. So you have to have that. That will be on the board. Question number 2 here, which is technically number 3. That question was exterior, so they should always add up to be 360 no matter what the picture is. 4 and 5 here, which is technically 3 and 4 on this practice guide, you just had to solve for A, B, X, and Y. They should have been ridiculously easy. I would expect something very similar on test day, where I just pull the problem from your book. You can easily find what the numbers are because you either know that the diagonals are equal, the opposite walls, opposite angles are the same. Certain angles have had up to be 180, that type of thing. And I'll kind of warn you on test day, like if they're angles or if they're walls, you can kind of tell if they have a degree on them or not. But they're ridiculously simple. Today we're going to start with, technically this is number 5, but it's number 6, and we're going to go through the rest of it. We're going to finish out our practice guide here today. We're going to probably spend the most time on number 6 today. That's the one we're going to spend a lot of time on. Just make sure you know how to do it. That is one of those problems that we've seen a while back, but we need to kind of review it because it could easily show up on the test depending on what problem I pull out of the book. So I want to make sure you know how to do it. And then we're going to spend a little bit of time, I think it's problem number 8 down below. It's one with the rhombus. We need to talk about a couple different problems that could be in there. But let's go through this problem. These problems directly out of your book. That one for sure. I remember doing that one in class one day. But to do these problems, what you have to do is you have to solve for x and solve for y. It says solve for both variables. Like on this problem, this is a rectangle. It's a parallelogram. But you can set these walls equal to each other. Right? Opposite walls are equal. You can just set them equal. So off to the side, you'd be doing 4x minus 17, setting equal to 2x minus 1, and actually doing the work and solving for x. Like, that's how easy it is. It's just a single variable. You just move the x's, move the numbers, solve. It should be a number. If it's a decimal, fine, so be it. It doesn't even require you to plug it back in. It just said find x and y. Now, the second one, the second letter is more challenging. This one, the angles are the same. These are alternate interior. You have to know that those, you can set those equal. I had a couple of people, I think on Wednesday last week, they were trying to add them up to be like 90 or adding them up to be 180. They're equal. They're alternates, right? They're alternate interiors. So you can just set those equal to each other. So 3y plus 5 equals the 5y plus 13. Then you can solve the math and figure out what y is. Move the y's across, all that good stuff. You should know how to do that as Algebra 1. Now, the only difference that could be here is that, if you think back to the problems we had in the chapter, and again, these are from section 6.2 and 6.4, certain angles have to add up to 180 on a certain picture, so maybe they gave me, this angle here and this angle. Well, those angles are different, but they have to add up to be 180. So it just depends on what the variables were. Maybe this is a 4x, and this was a 2x, fine. Add that, set it equal to 180. So it's 6x equals 180, and you solve for x. It could be that simple, okay? Just be aware of kind of what you need to do. That's really the only things we could do here. On this problem, since it's a parallelogram, opposite angles are equal, so you can set those equal to each other. Now I know that this one has 2 variables on it, so you'd actually have to solve a 2 variable problem. I'm actually going to do this problem for you just so you can see it. This is a system. It's a system-based problem. It has 2 variables in different spots. So you have to solve it like a system, stack them, do all that stuff. We've talked about this a while ago, but these are problems that were in the book that I think we need to be able to handle. We need to be able to do. Now, this problem, I consider this one significantly harder than the other one, but let's actually talk about how to solve it. So if I set those equal to each other at first, 2x plus 2y equals, what is that, 4y plus x. I'll move this around, I'll solve that equation, I'll at least like narrow it down, like simplify it. I really can't solve it, it has two variables in it. And then once I have this simplified, I'm going to stack it with the other equation. The other equation is actually using these two right here that are side by side, because those two have to add up to be 180. So that could be my secondary equation. So if I add the 2x plus 2y plus the, what is that, x plus y, that has to equal 180. Those are same side interior angles. So now I have two different equations. I can stack them once I simplify them. I'll simplify them here in a minute. And then I can solve using the systems stuff. But does everyone understand how I got those problems to begin with? But since there's two variables, you have to be able to stack them. But let's simplify that top one. That top one's kind of ugly. So let's move some stuff around here. Let's like subtract the 4y across over here. Let's subtract this 1x over here. And yes, that is a 1x. When I bring it over, I'm going to subtract it. And when I bring the 4y across, I'll subtract the 4y. So really this top equation, if I move these things over, I'm going to have a 0 over here. There's nothing over there. It's just I moved everything over. But 2x minus 1x, that's a 1x. And when I take the 2y and I subtract 4y, I get a negative 2y. So there's your top equation. That's the top one if I rearranged it. The bottom one, I could pretty much just add these x's together. That's 2x and 1x makes 3 x's. 2y and 1y make 3 y's. And there's 180 on that side. Bless you. Now I have them stacked, and now I can do all the normal stuff that we do for systems. Okay, but that's just simplifying this bottom equation by adding like terms, adding the x's, adding the y's, and making it simple. Okay, hopefully you remember us doing this. We did this quite a bit back in, I think, what chapter was that? Chapter 3, chapter 2, chapter... I think we had a couple in chapter 4. They do system. But how you actually solve this? You have to pick one of the letters. I'm going to pick the y's here. Doesn't really matter. I'm going to pick the y's. I'm going to make the y's the same number. So I'm going to make them both maybe 6's. So I'm going to multiply the top row by 3, everything by 3, and I'm going to multiply the bottom row by 2. Now why I picked that is because the y's are the opposites. One's negative, one's positive. So I won't have to do any sign switches. But I'm going to multiply the whole row by 3 on the top, so I get 3x minus 6y equals 0, because 0 times 3 is 0 still. And multiply the whole bottom row by 2, I get 6x, 6y, and 180 times 2 is 360. And yes, you have to multiply the entire row by the number. And now that you get the letter you picked, they have them matched and they're already opposites, I can add straight down. I can add those two rows. So if I add these together, that makes 0. So these cancel out. That's perfect. That's what I wanted to happen. This makes 9x. If I add straight down over here, I get 360. And I should be able to divide. And I should get, what was that, 40? If I divide that over. Let's double check. Is that a 40?
Yeah.
360 divided by 9? Yeah. 40?
Yeah.
And then I can plug it back in. Because now that I know the x, I can go to either one of these. I actually go to really these here. I can plug the 40 back in and actually solve. So, it doesn't really matter which one I pick. You can pick this original one here, you can pick that one, you can pick any of these. Those are the simplified versions. I might just pick that top one in blue. That one looks kind of easy. And I'm going to plug the 40 back into it. Let's do the math here. Let's take that top equation. Let's plug that 40 back in. That top equation was that 1x minus 2y equals 0. We're going to take the x, which is 40, and plug that in. So 40 times 1 minus 2y equals 0. That's 40. I'm going to subtract the 40 across. So I get 2y equals negative 40. Is that 0 minus 40?
It's 40.
And then, yep, divide by negative 2, and yeah, you get 20. And there's your x and y. Now, will I necessarily pick something that hard? No. But this is something I found in the book, and I want to kind of show you that's a style problem that was in the textbook. I just never assigned it as homework. I would expect something where, you know, you'd expect to see certain angles are equal, certain walls are equal. Seeing this, like you could set these equal to each other and solve, or you could add these together to make 180. That's why I picked that problem. I would expect something like maybe problem number 5 or 6, one of them is more challenging than the other, but not like overly difficult. I consider this overly difficult. It's like, it's way past what we probably expect. But it does have the properties that we've been talking about. You know, certain things add to 180, certain things are equal. You know, don't necessarily put a system, but it's good to at least see something like that to show you that the level of difficulty we could get into. That would be a really good Algebra 2 problem, I'm just saying. Okay, are we good with number 6? Okay, let's move on. Let's take a look at the rest of them. The rest of the problems are really straightforward, super easy. You just have to remember your properties. These are about parallelograms, so this second section and that top one kind of looks like a rectangle. We'll keep this one. But let's get to the next ones. All right, so next couple of problems, these are pretty straightforward, pretty easy. This problem, it'll probably be a rectangle of some sort. You'll have to do a little bit of math. Now, what I mean by rectangles, there's certain things you should know about rectangles. Number 1, opposite walls are equal. These diagonals in the middle are all the same length, all 4 of them. So if you know this is a 10, then all these are 10s. Because this is like the perfect center. That's a unique thing to a rectangle. That means you have a bunch of isosceles triangles in here. The angles in the corners are 90s. So certain angles on this picture have to be matching. You know, like for instance, like this tiny angle right here has to equal this angle here because it's isosceles. And so that means you can find this angle and then you can transfer it across, find those two. And you can find this missing angle next to it. So there's lots of things you could do with rectangles just because the diagonals are the same length, they're equal. Well, when you look at this picture, they told me ZY. ZY is this stick, that's the 2x plus 3. They gave me the WX on the bottom here, which is the x plus 4. And what can you tell me about those two?
They're equal.
Yeah, set them equal, solve for x. You can plug it back in, because they actually want you to plug that back in. They want you to find the length of WX in the very end. So once you have x, let's say x turns out to be a 1. Let's say that's what it is. X is a 1. You could plug it back in. So you could take the 1, plug it in here, and now you get 5. That's 1. So, questions? Yeah. So you have to plug it back into the WX stick, because that's what you're trying to find. Questions on what you could do with that type of problem. There's lots of stuff you could do there, you know, because certain pieces are all equal. I'll just pick one of the problems out of the book that you've definitely done in class as one of our little groups, but it'll be a rectangle-based problem. All right, let's keep going. I'll have a few left here. These get pretty straightforward. They're pretty easy. The last, you know, this problem is a rhombus. It will be a square. You know, that's what you got to be aware of. On this one, they give you the AB is a 14. This is a 14. Now you can find the rest of the pieces. So like, they want you to find BC, that's this thick. Well, what can you tell me about a rhombus? What's the definition of it?
All sides are equal.
Yeah, so what's BC? 14, that's your answer. Move on. The other thing you could do, maybe they give you this piece right here, maybe this is a 10. They could have you find BP, because it's a right triangle on the inside. Rhombuses have right angles, so you can do the Pythagorean theorem. You know, leg squared plus the other leg squared equals the hypotenuse squared. And yes, that is the hypotenuse of that triangle. And then you could solve for x. You know, you square this is 100, this is 140, or this is a 196. You could subtract that over, and you could take the square root. And that will give you the length of that piece right here. Because it's a right triangle. You could do SOHCAHTOA to it, which I'll have on the board if you need those formulas. But that's the type of stuff you need to be aware of. Those are things we did in class that you had to be able to do. You know, find missing pieces. Now, all the sticks are not all the same like a rectangle. This is 10, that one's 10, but these don't have to be 10. They're different lengths, as you can tell. So just be kind of aware of what you could be asked for. Now that problem is ridiculously simple, but again, I'm pulling one from the book about rhombus or squares. 9, 10. These are about traps. 10 could be a kite, so you got to be kind of aware of that. But on this one, you had to know like what the pieces are. QR is a 12, UT is a 22. This piece right here, VS, is the number that's directly in the middle of it. So whatever that number is, what do we say, 17? That made sense. That's the number directly between 12 and 22. Because how I know that, it's exactly 5 away. Exactly 5 away from each number, so 17 made sense. Now, how you do that, you could add the two numbers out, divide by 2. Maybe they give you this number, maybe that's your problem, maybe they give you this is 14, this is 12, well then this would have to be 16. Because they have to be equally spaced, that type of thing. So that's a problem you should definitely expect. You could get an algebra problem here. X plus 1, X plus 2, find this. Or maybe they told you this number is 18, find what each stick is. Fine, add these together, divide by 2, set equal to 18. Solve it out. It's an algebra 1 problem. Now, those are the types of things. I would expect a problem that you've seen in class, though. If you've done, now, those types of problems were on that latest homework, page 444, which is technically due tomorrow. And then the last picture is a trapezoid. Okay, now this could be a kite, but you just have to know little things about the actual trapezoid itself. It looks a lot smaller than what I have on here. Oh, there you go, never mind. But on this one, knowing that this one's isosceles, so because of the two walls, so that means certain angles would have to be the same. So they want you to find angle Q. Well, Q is not 110. You can see it from the picture. But what should it be?
70.
Yeah, because what do these two have to add up to be? 180. So this would have to be 70. This is 110. That would be this number. And then you could transfer the 70 over. Because remember, certain base angles have to be the same if it's on a trapezoid, on isosceles trapezoids. On kites, same idea, right? On kites, certain sticks are the same length, certain angles are the same. Only certain ones, not all of them. Because this angle here is definitely different than that one. But there's things about kites you should know, like they still make 90 degrees in the middle. They still bisect one of the sticks. You could do little things that we did in class on the homework, which is at page 444. So just kind of, if you're doing that homework, you'll see these two problems will directly be out of the homework you're doing right now. That's why you want to work on that. Okay, I'm not trying to pick super difficult problems. I'm just trying to pick problems that you know your properties, you understand the theorems about them. Certain walls are the same, certain angles are the same. Can I solve it very quickly? There's no proofs on this test, none of that. There's a lot of vocab, obviously, you can kind of tell that, but you need to be kind of aware of what you need to be able to do. I would say I would definitely be worried about the rhombus problem. There's just so many different problems we had in the book about those. Definitely check your vocab and check your bubble. Hopefully you submitted the bubble to me. I know a lot of people were sending me emails over break about whether they got their bubble submitted with all the theorems and stuff on. Those are things I was looking for. Those scores will be in the grade book here. When is our test? Tomorrow. Be aware of that. We need to get this done. This needs to be turned in. Homework, page 444. That assignment is your ticket for the test tomorrow. I don't believe I have anyone's in here. Maybe I do. Maybe there's one. I have one. I have a list. So that's the only persons I received in this room. So everyone else needs to get that done and turned in. Okay? But again, if you're not sure, watch the video. I'll post this video. I'm going to try to post this before the end of the day. Okay, before the end of the day today. I'll try to get this posted so you can watch it tonight if you need to.